Hi, thank you for joining us and welcome to today's session. My name is Amelia Smith and I support the marketing efforts of Sea Machines Robotics. Before we get started, I'd like to tell you a little about this project and introduce today's presenters. A little background first. In October, Sea Machines announced that First Harvest Navigation would upgrade its Captain Ben Moore hybrid vessel with our SM300 autonomous command and remote helm control system. This will make the vessel the first hybrid cargo vessel to utilize remote crew assist technology while generating zero emissions. To tell you more about this exciting initiative are our presenters. First, we have First Harvest Navigation's President Bob Kunkel and Technical Director Micah Tucker, as well as Phil Bourque, our Director of Business Development at Sea Machines. Now, before I turn the webinar over to them, I want you to know that if any time you have questions, just type them into the box below and we'll address them at the end of the presentation in a Q&A session. Oh, and a recorded version of this webinar will be emailed to all of you, as well as posted to our website at seamachines.com and all of our social channels. With that, I'll turn it over to Phil.
Yes, thank you, Amelia, and thank you, First Harvest and Harbor Harvest for being here. Welcome to this Sea Machines webinar series. I am Phil Bourque, and I'd like to tell you a little bit about our company and what we're up to, what we do, as well as give you a quick introduction into marine autonomy as Sea Machines sees it. We'll move into some use cases that feature Sea Machines and that Sea Machines is currently employing in the field today. And then after that, we'll go into sort of a one-on-one discussion with Harbor Harvest and the First Harvest crew here on how they're going to benefit from using this technology. One thing that I think we'd like to just emphasize is that our company is really focused on building a product, and you'll see that throughout our presentation and talk today. All right, Amelia. So what is marine autonomy? Essentially, all autonomy is categorized into some kind of continuum. And in the marine community, we use a 0 to 6 continuous scale, with 0 meaning fully manual operations and a 6 meaning fully autonomous with no human intervention, or 100% unsupervised operations. Currently, Sea Machines systems fall somewhere between levels 3 and 4, meaning those decisions and actions are performed autonomously with human supervision and authorization and/or supervision. So in some cases, high impact decisions, though, allow human operators to intervene and override. So both of these are described as a human in the loop system. That's where we are today, and we're quickly progressing into the other stages, but there's a lot of work to be done to get there. So Sea Machines and what we do is, again, I mentioned we make products, and we're essentially a software company, but we have developed hardware to get that software into the marine environment on boats. So our product, essentially the SM300, is a series of hardware and software, as well as control and command and control algorithms that are all displayed through a user interface. The hardware itself is designed to be fairly compact. In fact, that box that you see there is about 20 by 20 by 8 inches. And that is able to be applied on a lot of different types of vessels, whether they be traditional screw, jets, thrusters, outboard engines. We've designed it to be fairly scalable. The important things here is that this is a product-minded solution that enhances predictability through the automation of repetitive transits. And this is specifically the benefit that we're providing Harbor Harvest and First Harvest Navigation. The second is the ability to offer a remote command solution that offers redundancy and makes the helm accessible to mariners wherever they are, right? And in this case, it's going to be local in New York and Connecticut. All right. A little bit, just a quick view of what the system looks like, sort of in a skeleton view, I guess you could say. The SM300 being the core, and view it as an additional control system that gets installed on the boat with basically the option to use it or not. So the traditional controls stay on the boat. The SM300 gets installed as an auxiliary control station, and then it integrates with all the other features and sensors that are typically used. So steering, of course, propulsion, comms, positioning, and the sensors that would normally give an operator a sense of where he's at versus traffic. That is all displayed to the customer or the operator with a user interface that ingests that information, processes it, and then provides it back in the sense of creating menus and localization information that can be digestible and easily processed by that operator for decision making and remote monitoring. Go ahead, Amelia. So autonomy today. We should start with pilot assist or autonomy with humans on board. The first use case involves smart route execution or waypoint autonomy. You set a mission, you decide how fast you want to go between waypoints, whether or not you want to stall or loiter on a specific waypoint, while always taking consideration what's going on around and underneath the boat. And that's where we employ obstacle avoidance and obstacle detection and collision avoidance, as shown here on the top right video. So as you're aware, there's always the propensity for dynamic on-water situation, whether it be an encounter with another vessel or marine life or some kind of landmass. So based on the parameters you have set the system to react to, the vessel will avoid such obstacles per col regs. We do follow col regs with our collision avoidance system. A good chunk of them. We don't have it all figured out, but we're getting there very quickly, and we'll talk about that shortly. So then you can get into command modes, and command modes are more tactical. So collaborative autonomy, essentially a digital tether between two vessels or a mothership and a daughter ship. And the idea here is to enable two vessels to perform the same mission at the same time for the purpose of force multiplication or swarming. And remote helm and remote operations would be slightly different. Remote helm, shown in the middle there with someone with a line of sight application, where a mariner is using a belt pack to operate a vessel from shore or a second vessel. Our remote helm has a range of about a kilometer. And in this particular photo, the guy's controlling a skimmer vessel, something that we did with MARAD in the US about 1.5 years ago. So for remote operations, on the other side, involves an operator commanding a vessel or multiple vessels from land, where a second vessel wherever she needs to be, and effectively anywhere in the world. And so this includes setting and executing missions with full situational awareness and pretty much anything you can do to command the boat from the wheelhouse, including aborting missions or customizing those missions on the fly. You can do that right from your office. So if you see in the bottom right of the screen, there's some video footage that would be normally be able to be enlarged. Those cameras that are in that TV screen on the right, on the bottom left. So you can enlarge and get full situational awareness of what's going on where she wouldn't have line of sight. So taking this concept to first harvest navigation, we will be employing an SM300 on the Captain Ben Moore. And that vessel normally does a transit between Norwalk, Connecticut and Huntington, New York. We'll be able to pass this on and let Robert and Bob, Kunkel, and Micah, be discussing what they are going to be using the system for. But ultimately, if we go to the next slide, the whole vision at Sea Machines is to do exactly this, to create the technology that allows human supervision, but in a remote and autonomy from a remote location. We're not saying we're going to take people off of boats, and we'll talk about that. We're adding a layer of technology that enhances the overall predictability and the ability to conduct this operation safely. And it's an exploration of how this technology is going to be applied and built upon. So with that, I'd like to talk to you a little bit more about Sea Machines, just in the sense of why we're here, why I think Harbor Harvest hopefully will have this in their own words, but why would anyone choose our company, and what do we do that's different? We're based in Boston, originally founded in Texas, but based in Boston largely because of the great autonomy talent pool that is in Boston. And our products are operating around the world. We've got products operating with the government, within the commercial space, within a variety of different sectors and applications. I mentioned that we are very much a product-oriented company. We don't make solutions in the form of projects. Of course, our products go into the projects just like this, but they're not custom built for that project. And I think that's a big difference in how we approach things. We are working with class and state regulators, and it's been a great experience to sort of overcome some of the challenges and also address a lot of things to make our product safer and meet rules. And we're going to continue to do that specific to this project. And we're the only marine autonomy company with a continuously operating test fleet. We've got 3 vessels now, and we're going to be getting some more vessels this year. 2 of them operate every day in Boston, 360 or close to the full year, rain or shine, and even in snow. So we're creating and we're experienced with a dynamic variety of domains and environmental conditions. So with that, I'd like to kick it off to Bob and Micah, and really appreciate you guys for being here. Hopefully tell us a little bit about your company and how you'll be interacting with our product. That'd be great.
So good morning, Amelia and Philip and everyone that's attending. Hope everybody's healthy with everything we're going through here with COVID and the pandemic, especially here in the United States. So just as a brief background, First Harvest Navigation and Harbor Harvest are 2 companies in a network of about 5 different companies that do construction supervision, design integration, and design. We have a company, Amtech, that does that construction supervision. First Harvest Navigation is our vessel management and owning company for the catamarans that are going to be introduced today. And Harbor Harvest is a food distribution company. That company is part of a vertical integration where we're trying to reestablish coastal regional transportation for family farms and artisan products based in the New England and New York area for now. There is a documentary film that's just been completed on the project. It's called The Last Line, which deals with how we look at climate change and how the marine industry has to address that. And we believe that the Sea Machine system, the SM300, is going to play a big part in helping us look at energy efficiency and how we operate the vessel. So we have 1 vessel in operation right now. She was part of a selection by the workboat industry of top 10 build in 2019 out of Director Shipyard. We're a partner with BAE Hydrogen up in Rochester, New York, who does our propulsion work along with Cummins. And we also have a nice relationship with Furuno, who has supplied all of our navigation equipment on board, or the majority of it. I'll let Micah start to talk about the technical side. So I just want everyone to know that this is a project that's going to develop correctly, so that the term autonomy is understood by the marine industry based on what we're going to do here between the two companies. And Micah, I'll turn it over to you to discuss how the retrofit took place.
Thanks, Bob. So there's a few things that make this project kind of stand out from some of the other ones that Sea Machines has been involved with, and kind of tailor it towards the use of this SM300 system the way it was designed and built to begin with. So the Captain Ben Moore is a hybrid electric vessel. So it's an electrically propelled vessel that is powered by lithium-ion batteries. So what does that mean for this project with the Sea Machines system on board? It basically means that the vessel is smart to begin with. It has an onboard power control system, including propulsion and steering controls that operate on a lot of the same protocols that the Sea Machines system uses to begin with. So this was kind of a tailor-made project, to work into this SM300 system to begin with, because we're already operating basically on a fly-by-wire system that's all manual controls on the vessel. So the vessel is powered with its electric motor through lithium-ion batteries all the time. We have diesel generators on board that we use as range extenders. They will automatically start and stop to recharge the lithium-ion batteries as needed, but all the time the vessel is operating electrically. So this was a system designed and built by BAE Systems, and it was integrated by Director Shipyard during the construction of the vessel. And what we've done here is we've incorporated the SM300s kind of as a secondary control system on board for operating basically just the throttles and steering controls, and integrating with the navigation equipment. So the vessel is used, as Bob said, for cargo shipping across Long Island Sound. It's a fairly predictable route, but there is a good amount of commercial traffic in the Sound at all times. So the SM300 system is going to be used basically as an alternative second station or third station for controlling the vessel. The system incorporates AIS, radar, our onboard camera feeds. It also uses our onboard GPS system. We've added a GNSS sensor, uses our onboard depth sensors and navigation charts all in one display. And it integrates that all with the SM300 system with the remote control capability and some limited autonomy functions. So that allows us to operate it from our command station, which Bob is located in right now, as well as semi-autonomous operation from the boat itself. And again, this is all with the human in the loop scenario, as Phil was describing before.
So I'm going to pick up on what we've seen in traditional shipping. Most of our employees or people in our network are former merchant seamen, former military, or former shipyard workers. So what we looked at was, what are the issues that traditional shipping are actually dealing with, and how can that autonomy and the SM300 actually add to, number one, safety, because that's the first look that we were looking at, is can we provide a new set of safety degrees or safety issues that would make the vessel easier to operate and safer to operate. We believe that the network, or this platform that we're dealing with across Long Island Sound, delivering cargo and passengers, allows us to see how the system will react with recreational boating, and yet provide a platform that many of you that are in this webinar right now as attendees may be able to easily attend and see how the system and how the operation works. We do right now, our network of companies oversees 13 tankers at sea and 3 bulk carriers. So we're looking at how the system will eventually move into blue water shipping. I want to make it clear, like Phil said, we believe that the term autonomy kind of took the wrong turn when it first came out, where everyone was talking about removing a crew. We're looking at this as something that can enhance the crew's capability. Maybe take a look at how it affects rest periods, which we see problems with on the tanker fleets, and whether or not we can actually find efficiencies in our cargo operation where our crew, with the confidence of the SM-300 system operating the vessel, can work cargo and get cargo ready and save us some time when we get to the docks of loading and discharging our break bulk that we deliver nearly on a daily basis. So on the shoreside support, I am sitting in what we've built up as our operational centers. The vessel, prior to installation here, as Micah is working through drawing review and approvals with the U.S. Coast Guard, I've already taken the initiative to put cameras on board. The vessel can be tracked by camera, and a Verizon partnership that we have on 5G right now that will allow us to be able to see the vessel make its voyage across from more than several different angles. And what we're looking to continue on with is to be able to provide our crew on this vessel to begin with shoreside support that has a similar skill set that they have in an operational mode should we go remote. So safety is the first thing we're looking at, that new layer of navigational safety, that new layer of operational efficiencies that the system can provide to us. And again, because of how we have that partnership with BAE Hydrogen and how the vessel actually operates now as a smart vessel with daily information that's sent back to the manufacturers on how the system's working, what our efficiency ratings are, how we're reducing emissions, which is what our program originally was based on. It was to remove truck traffic from the highways in the New England and Connecticut area, where trucking was anywhere between 6 to 11 hours, sometimes 2 days out into Long Island and the Hamptons. And the Harbor Harvest boat does that same trip in about an hour. So traditional shipping has its issues, and we're hoping this technology and our platform will show everyone how we can start to correct some of the issues that are there, or at least assist and add another safety measure.
So I just want to take a quick second. I see some questions pulled here. The Captain Ben Moore is a subchapter T vessel, and the mariners are licensed to a minimum of 100-ton credentials, just in case other people are wondering, and I saw that question pop up.
So I'm going to continue with Micah on proof of concept. Again, where you're looking at the chart and one of the camera photos from one of the previous slides of where our operating itinerary is. We're readily accepted to be in the New England area. We're available for the vessel to be attended to see how the system is operating. We're working very closely with the U.S. Coast Guard to make sure that design application and the drawings and approvals are done correctly, and reach those approvals before we go into full operation and final installation. This system, from an operating platform and a test platform, if we're operating more or less midwinter and early spring, there's relatively less traffic, not as much traffic on the route, for everybody to get used to how this system is going to operate in the several different modes that Sea Machine is providing from us. The remote control belt application, for lack of a better word, will be used for docking and undocking in the terminals that we're attending in Norwalk, Connecticut, and in Huntington, New York. So the crew will get operation experience from that. And then as we start to get more into late spring and early summer, we see a lot more traffic in that scheduled itinerary that'll help us determine how the system is going to identify certain obstacles and build further on the collision avoidance system. So again, we're operating a break bulk operation that's loading and discharging cargo at these two terminals. The documentary will let everyone know that we're looking at trying to rebuild a coastal fleet that's a gentrified fleet that is entering areas of wealthy marinas and deals with the fact that because we have addressed these environmental concerns and climate change, also understand that the vessel comes in and out of port without any noise and without any disruption. So these are all areas that we think the SM300 system is going to help both us improve our route predictability, make our efficiencies better as far as beyond a normal autopilot operation, and also be able to start looking at how the vessel will be used for operations beyond just passenger and cargo, whether it becomes research or whether it continues on into actual first responder or responder issues with flooding and everything else. I mean, the vessel can just about hit any coastal area here with a 3.8 foot draft. And we're also looking at how the hybrid application and this autonomy application can also push us into assistance on construction supervision and offshore wind and larger vessels moving up and down the coast. So it's a system that we believe on coastal shipping side and close quarter operation is going to be very successful for us.
I just want to touch on, Bob, you mentioned efficiencies for a minute there, and I think this is another important benefit for Harbor Harvest and First Harvest Navigation is our vessel is an efficiency platform, right? It's based on limiting energy usage and using that energy as efficiently as we can. And the predictability of an autonomously controlled vessel adds that efficiency level, and certainly we can see some gains there as well. When you look at the human interaction with an electrically propelled vessel, there are different different acceleration and deceleration curves based on the human hand, and you may have some captains that have a heavier hand and accelerate quickly, which leads to kind of wasted energy on our side. Whereas with the the autonomous controls, we can see what the proper curve is and the most efficient curve is for accelerating the vessel and the entire route itself. And we can program that in and allow the vessel to operate with the least energy usage possible as well.
So on the remote command station, like I said, we've set up our operation systems, our internet systems. The vessel has its own internet site and carries it through on the operation. The people that we're looking at putting in play here as we go from one step and continue on through that 1 through 6 steps that Phil actually had introduced, the people that we'll have in our operating office will have that same navigating skill set, that same operating skill set that you would see on the vessel to support the captain and the deckhands and the people that are operating it on board. One of the things that we've looked at is the remote command station is our operation as we build geographically is being determined as providing crew in an airline type of scenario. We don't have live on board accommodations. So we're constantly transferring our crews back and forth to where the vessel will be operating from. And at that point in time, that's where we'd like to look at whether or not, as we're transporting crew or we're one man short on how we're going to be dealing with the operations that day, based as chemical, cargo, or actual passengers, that we can start looking at using that remote command station to facilitate the one man that may be missing, or the one man that, missed a plane, or someone that was, moving from the New York station to the Connecticut station. So the remote command station, as much as it's an oversight issue right now, where we're watching how the vessel is operated with that human interface, it's also how we're going to be looking at how it can also affect our crew complement as far as moving everyone around from vessel to vessel, and as we build up this fleet. Transfer of data. What makes this system fit nicely on our ship is our propulsion data is transferred to BAE Hydrogen every day. So they see how the propulsion system is running. So we'll now have control over our maintenance and how the propulsion system is operating. And we'll also have a database and control on how the vessel is operating from the pilot house, navigational wise, and how that navigation equipment is operating. So that's another level that we're seeing is going to help us reduce on the maintenance side. Micah, you have anything else on that side?
No, I think you covered all the points there.
I'll add in, if you can go back, Amelia, I'll add in, I mean, just to reiterate our system and the data that it is processing on board on that screen on the left. So the remote operator has visibility into all the vessel parameters, so it can understand and see what's happening with alarms, conditions, speed, heading, all that stuff. But also the situational awareness from radar, targets, AIS, the depth. And so really does get a sense. What we are doing to improve on that, those photos on the bottom right, or the videos, can be all enlarged, and that whole screen can be a large camera view. But what we are also doing on top of that, our company is working on target perception, basically, and target tracking and target detection and classification of objects on the horizon with special software that has been built by Sea Machines for the last couple of years. We're early in the development of that, but it's basically machine learning and AI that can categorize basically a sailboat from a rock, find and identify a marker on the horizon, and then distinguish between targets that might not be normally detected by radar, right? Maybe a paddleboarder or someone on a canoe. And the ability to be able to pick those targets up off of the horizon and then send them back to the remote operator who's miles away or could be miles away from the vessel. It adds a lot of safety, it adds a lot of capability, and it adds that predictability that we spoke about. So that's sort of part two of where we're taking our product and our technology, but this is the ability for that remote operator to be empowered and enabled is going to increase, which is exciting.
So I think both companies are going to just address this. From our construction supervision and design integration, we do a lot of work with all of the IACS class societies, ABS, BV, DNV. On this project, Micah is working very closely with the U.S. Coast Guard Sector Long Island. I'm sure New York will be watching us also. Understand from Micah and I, this is the third hybrid vessel that we've actually built. The first one being the Spirit of the Sound in Norwalk, Connecticut, that was done as a research vessel. Micah took over and handled the CUNY vessel that's doing research down in Rockaway Inlet. And then this vessel is the first design change that took us into cargo. It's the first hybrid cargo vessel built in the United States. So we've been in touch with local Coast Guard, MSC. Mike is putting together the drawing package, FMEA, and different issues that the Coast Guard is looking at. I think cybersecurity will be one of the larger look-sees on how we're going to address that when we start looking at how the autonomous system is operating. And I think we'll see a lot of work both on the class side and the U.S. Coast Guard side. This vessel here is not a class vessel. It's not required under the subchapter that Micah had told everyone about, but we are closely involved with the U.S. Coast Guard for the simple fact that our companies have done a lot of first LNG bunker barge built in the United States, first hybrid. So we want the Coast Guard and everyone to understand that this is going to be done correctly. The platform is there for inspectors to come and ride the vessel and see how it's doing. It's easily accessible. And I think that's one of the reasons that this installation and this platform is going to be very successful with Sea Machines.
Yeah, so
and I'll add, go ahead, Micah.
I just wanted to touch on what Bob was saying there about the firsts, right? So there are obviously no regulations that exist right now, either describing how the system should be installed or how it should operate. So we are working very closely with our local Coast Guard, Sector Long Island Sound, to make sure that we are developing those operating guidelines and installation guidelines. Not necessarily too many regulations, but to make sure that they're comfortable with what we're doing and we're comfortable with what they'd like us to do.
I'll just add on our side to that, Micah. We Sea Machines have kind of self-imposed the opportunity to test and get our product approved with BV for at least the marine electronics side of things, from electrical environmental requirements. We're going to be continuing those efforts as the rules do come out, right? But we're also entering a type approval process with a classification society, and we've invited a specific class society to participate in this program to review the technology and the operations. And hopefully, we'll be able to share more about that later in the coming year. I think I would also just like to add. I mean, we believe that our autonomous systems can provide substantial value working with this current vessel manning, and that deploying the autonomy with current manning is the easiest and most organic form of technological adoption. So, when you consider the technology enabling direct crew reductions, as it has been doing for hundreds of years, there will be further efficiency gained by autonomy in the future. But this is just a very, very first step in working alongside crew. And, maybe it will get there eventually. But I think the first step is to actually put this in the hands of the operator and in a safe way. And we're doing just that. So, I think we could potentially have a little bit more of a casual conversation here at this point. This is sort of our last slide for folks. So I think if there's questions that the attendees would like to pose, we can start answering those. We can start answering some of the questions that have been posed. If you go ahead, Amelia.
Yeah, I was just going to say, we're actually running a little tight on time. So we do have some questions that I can ask to you guys. These are obviously from the question and answer chat and chat boxes here. So the first one is, what communication technologies, systems, and protocols do you use? Vehicle to vehicle, vehicle to land, bit rates V2V and V2L, both downstream to V and upstream from V. Can any of you answer that?
Yeah, so from a data bandwidth perspective, we try to keep that load as small as possible. I mean, even though 5G is right around the horizon, which is awesome, I was excited to turn on my phone the other day and get all that data real quick. The data is in a lot of the world and in a lot of the marine world is scarce, and so the ability to make sure that your command and control messages are as small as possible is obviously important. We typically are sending up about 4 megabits a second with several cameras on, as well as with our system command and control messages going back and forth. So, you know, we can actually customize that by turning some of the cameras on and off, and there's different things we can do within the UI to lighten that data load. But 4 megabits a second up is a good number. The down rate is very small. It's like in the tens of kbps. And then the system itself, if you just shut all the cameras off, the systems itself it's less than 150 kbps of command and control messaging going back and forth.
Okay, great. And the next question, what are your operators' U.S. Coast Guard licensed maritime credentials?
So they're 100-ton captains right now. The vessel is under 50 tons gross, so it's a relatively small vessel, but it is, you know, it's a passenger vessel, so it's subchapter T, so all of our captains have to be licensed.
Just to add on that, to see industry involvement, you know, we're working right now off of you know, daily updates on cargo movements, but we've had several different captains and skippers come through from Maritime Academy grads that are holding unlimited license. So there's a lot of interest in the industry on actually learning how the hybrid does operate under electric on the issues that Mike had raised. But we've had Kings Point on board, we've had New York Maritime on board, we've had Mass Maritime on board with different operators that came in to intern and learn how to run the system.
And also, just to be clear, I know we've said it a few times here, but we are not removing licensed crew from the vessel, right? This is just another means of adding a layer of supervision and control on board without taking those crew members off.
Okay, we have another participant who's wondering if the reduction in crew fatigue could also be a benefit of the SM-300 aboard your vessels.
I think I touched on that a little bit because of what we see in our operations of a tanker fleet. I think it could. I mean, understand, I've been on the test vessels out in Boston Harbor, and at any point in time where we have the confidence in this system on remote operation or an operation with that human element still being on board, at any point in time where the captain can kind of, for lack of a better word, relax a little bit and step away from that pilot house, it is going to add to how, you know, rest is going to be analyzed here with the system. So yes, we do believe on rest period, on watch standing, on areas that, you know, can be addressed, you know, in the blue water ranges when we start to work with Sea Machines to get this into larger vessel construction that we do. I think it's going to add a lot to that rest period issue moving forward.
Great. Okay, and we have another participant who is working on small ASVs to act as a force multiplier in port security environments. Could this system be miniaturized for something like that?
Take that one on. Yeah, you know, we haven't put our system on boats smaller than about 15 feet. I think is the smallest. So we aren't, you know, I guess the way to I think describe the threshold is the equipment in the SM-300 is basically derived from classed components from parts that are industrial grade. And so we've always, there is probably a limit. I don't see our product going on boats smaller than about 12 feet. One is size and weight. I mean, the box, although it's small, it's 20 by 20 by 8 inches, it weighs 60 pounds. So you start getting into a really small boat, you know, for port security. If you're imagining something, you know, 10 feet, I would say no. If it's above 10 feet, yeah, it's definitely a possibility. And we have been engaging with some inquiries to that effect. We just haven't done it yet. We do work with a lot of military applications. So we have some groups in the US, DoD folks using our system, both on the autonomy side and also on the perception side.
So touching on that government topic, there's another question here. that would like to know if multiple boats can be controlled to operate as a swarm, or if this is a one-on-one situation with one vessel controlling another.
Yeah, so earlier in the presentation, we talked about collaborative work or collaborative following, where we have like a tether between one boat, mothership, and another vessel, which would be autonomous. That is right now it's a one-to-one relationship, but we are engineering the effort to do multiple vessels, being able to control multiple vessels with one user interface and one easy sort of management. So if you could imagine, I wouldn't call it a swarm where each vessel is doing different things, but we do have the ability to manage multiple vessels relative to one vessel's position, and then do some unique things with formations and distance of each vessel from that mothership. Great.
Okay, we have another question here. This is actually from the STAR Center, Training Center down in Florida. How are remote shoreside operators trained and assessed in their competency? What additional skill sets or training do mariners require when employing this technology? And are all remote operators credentialed by the U.S. Coast Guard?
Well, I'll start with us, because we know the STAR Center well, and they're a little ahead of us on that issue. We would expect that anyone that's sitting at the remote station has the same credentials as the captain that's on board, or the mate that's on board that's running that pilot house. So we would look for that education base, most likely to come out of the state academies, and number two, to be U.S. Coast Guard certified. We'll work that out as that remote station will be there. Mike and I are engineers. I happen to think that Mike is one of the best boat handlers I've ever seen. But at the same time, as much as that capability may be there for the two of us, I think it's important that the remote operators have that same skill set and that same certification that the boat requires.
Great. Okay, and then this might be another question for you, Bob or Micah. If a vessel is carrying passengers, what is the protocol in the event of a medical emergency, such as man overboard?
So for us, nothing really changes. We still have that crew on board. We still follow the same emergency procedures that we would normally. Here, we just have an added layer of an additional kind of operator if we needed it. So if there was a large enough emergency on board and it called for more hands on deck to actually mitigate the emergency, then we have a remote operator that's capable of either maintaining position of the vessel or taking it to a safe harbor, and frees up an additional mariner on board to help out.
Okay, great. We have another user who would like to know about the collision avoidance capabilities. They're curious if the vessel cameras are providing that, or if that's coming from another source.
So on the collision avoidance capabilities, currently we are prototyping camera-based obstacle avoidance with surface targets in Boston. That is right now not our intent to bring that into this project. But at least for the next 6 months, as we will need to mature that technology in order to put it into a fielded product where actually it's being used. There's a lot of work to be done there from Coast Guard approach, right? Like we're not trying to create total equivalency with that right now, but that will be something that is released in I would say 12 months.
Great. Okay, we have another participant wondering if shoreside operations can override manual operations. And for the Ben Moore specifically, can the SM300 system assist with battery power optimization?
So we had this conversation yesterday, actually, in some preparation for our discussions with the Coast Guard. Manual operations on board the vessel always take precedent because that is the human interaction, and it is, it's the closest thing to a real real interface with the most amount of input from actual events that you can get. So there is always that precedence that manual operation on board the vessel will take control no matter what. And then for the second part, can it assist with battery power optimization? And the answer is absolutely. And it is, it's based on data collection and route optimization, given wind and tide and drift. So we can always improve, the energy usage on board based on our route and our speed. And this is one way to do it, with extreme accuracy.
Great. Okay, and we are running a little tight on time here. We'll have to watch the clock. We've got time for maybe 2 more questions. And I do want to point out that there's an email address there on the screen. It's sales@seamachines.com. For any questions we don't get to, we'll try to address you via email. You can always send us a note as well, and we'll respond to you that way. We'd love to have a conversation with you offline. All right, so related to that last question, when the onboard crew is not in the wheelhouse, how are they notified when there's a situation that needs attention?
So the system, the remote command system and the software that we've provided has a variety of alarms, right, for the vessel itself. And upon those alarms actually happening, there's an audible and a visual alert. There's also a microphone that the SM300 can ingest and be able to take information from the vessel and vice versa beyond radio. So from the aspect of the vessel traffic and situational awareness, if the event collision avoidance with radar and AIS and or depth is triggered, there's also that same audible and visual alert. And it's basically that we've designed it to not sound like another beep on a ship bridge. So it is something unique and something that will get the operator's attention.
We've also kind of discussed, for some future upgrades, although it's not available just yet, having an interface that the captain or the mate can carry with him when he's not in the wheelhouse to allow that kind of oversight on what's going on from similar to the remote command station.
Great. Okay, and for our final 2 questions today, these come in from ABS. The first one is for all of you in the group. ABS writes, first generation forms of automatic vessel control involved autopilot for heading maintenance without manual helm intervention. Dynamic positioning systems utilize redundant positioning reference systems and environmental sensors to feed cowman filtering for automatic station keeping. Both of these traditional control platforms rely primarily on sensors to drive a predictable system response, which can be tested through established trial procedures. However, next generation vessel controls are utilizing artificial intelligence to inform vessel behavior. How will testing, validation, and certification of AI-driven control systems compare to legacy systems of the past? In what ways will third parties and regulators need to adjust existing standards to be relevant for such technology?
Yeah, I'll take that on. It's a really good question, and the heart of it, I think, addresses the question of subjectivity, right? And like how the MLAI part of it will be judged according to that subjectivity. So I would say this, that while we've been working with MLAI to develop a novel sensor capability for the last 2 years, it shows great promise, but it still has some significant development before true operator equivalency can be reached. But as that sensor matures and is ready for testing, I think we're going to start to see, and we're going to need class societies to develop those standards of performance. And then I think a way to reduce that subjectivity and create the testing, right? I think simulators are a really good approach for testing and validation of the software algorithms, right? In trying to break the AI. So, okay, how good is your software? You know, run it through X set of, just from a simulator. You start with a simulator, then you work from there. But how good does it work in various weather conditions, sea states, all that kind of stuff that you can control in, you know, thankfully the modern simulators have gotten so amazing that you can do those things. And so I think that'd be a good way to address it. That's what we've done at Sea Machines. We are working with, you know, we've got the software development teams, but we also have the ability to do our own in-house simulations with some stuff that we're working on. But there's a lot to learn, there's a lot to grow before we can actually get there and work with those class societies to that effect.
Okay, great. And the second question from ABS is, safety in the marine environment is largely about understanding the limits of equipment and personnel and staying within the boundaries of those constraints, typically with some healthy margin for error. With traditional vessel position and navigation control systems, environmental envelopes are established to define wind, wave, and current boundaries for safe performance. In what ways are AI-driven navigation control systems contained, and how are these unique aspects managed in terms of design or operational risk?
Yeah, it's another really good question. And I think I'd like to answer it in two parts. I'd say that, you know, the AI-driven navigation is really only as strong as the robustness of the database behind it. So, meaning, does the data really truly understand the specific environment of operation, or where did that data come from versus the application where it's being used in the moment? For example, can a database developed in Northern Europe perform the same as a database in the Gulf of Mexico? The light conditions are different, the wave periods are different, all that kind of stuff can be different. So from experience, we can offer that there is a challenge to solve in this area. And so what it'll take is a really robust set of data that creates universal reliability. We've built, and when I talk about the data, right, what I mean is what surface targets look like on the horizon, right? Being able to pick apart boats from different types of boats, different sizes, in different light conditions, different weather conditions, et cetera. And those are the key, right? That's the MLAI part of it that will feed into the control system. But so going back to that, we've built a database of about, right now, it's 10 million annotated images that enable a basis for initial testing of AI integration. But there's a lot of work that's left. So again, the robustness of that database is one thing that I think right now it's constrained. The second piece of it that I would say, the second piece of the response is that those ML and AI databases are only, and the background processing logic are only as strong as the reliability of the sensors processing that live information. And so I think there's also a second part of opportunity for both industry like us and class to define like the redundancy for the sensors picking up that data and the quality of those sensors, how far we're going to be able to pick objects out. And again, all to create equivalency. And in terms of creating that equivalency, it's going to be some time, at least the way we see it. But you know, I think that there's a lot of steps that are being made towards that. So you know, we gotta walk before we can run, crawl before we walk. So
I'd like to thank everyone on the panel and thank everyone for tuning in. We are out of time, unfortunately. We wish we had more time with you. But again, if you'll email us at sales@seamachines.com with any outstanding questions, we'll try to follow up with folks who we don't hear from. We'd love to talk to you offline and help you learn a little bit more about our product, and we'd like to hear what you're doing as well. So special thanks to Bob and Micah. And with that, we will close the webinar. Thank you.